Kim and my team project member is Kim Ho-young Park Sung-hyun. And now, today I will speak about our team's project about personalized image captioning. Sometimes we want to share our photos in SNS, Instagram. We also write additional hashtags like selfie in birthday, but also we don't want to generate this picture as is. It should be more descriptive or emotional, and many people want to use more novel words than boring expression. So we try to find the latest work and can get it. In CVPR 20007 paper, this paper's contribution is in user context encoder. I will explain in next slide, and this baseline evaluated in both hashtag prediction and post generation task. The baseline uses three pictures. One is image picture, second is user context. It can be extracted by referring users' previous expression. And finally, for avoiding gradient vanishing issue, they also use previous generated word. But it has some problem. The main problem is we have a situation that we can know about user's context. We have the user who use social media first time or don't agree to provide personal information. In this case, we don't know about user context, so previous method doesn't work in this. So our challenge is this: make a caption and hashtag when we don't have user context. Also, it looks like cross-site problem cause we can solve problem with lack of information about users. Our baseline is this: train alternative model with user context, but test without user context. Then use this model to evaluation, caption generation, and hashtag prediction tasks. This is the result of baseline. As we expected, without user context is worse than with user context original one, and the bold things are our baseline to overcome. This is our method. The main idea is this: users who upload similar images use similar words, even if they are new users. So we create a fake user context by finding most similar images. If we find most similar image, we use that image context as fake user context. To do this, we use ResNet to extract image picture vector, then calculate similarity between image picture vectors. To apply this in here, we have some restriction. So we change our method a little. First, we don't search for images to get most similar image, but we set the threshold, and if we find some images whose image is more than the threshold, then stop searching. This is because we have a time restriction. Then fill user context with user context of found image. This is our result of our image. As you can see, it has a huge performance increases in hashtag prediction, but it doesn't work well in caption generation. The reasons we think are that caption generation is more harder problem than hashtag prediction because it considers word order and it uses more words. So we need another method to improve performance. Our next method is augment training data. The original model is trained by one's user context, a new model is trained by others' user context, and we train this model from best performance original model. And it has the same restrictions in realistic, so we set the threshold like above 1. This is our result. Now our method scores are better than without user context scores. This is conclusion in future work. Our project conclusion is this: making fake user context helps to solve cross-site problem, and especially fake user context shows strong performance increase in hashtag prediction. And you can solve this problem better like this. First, you can augment more dataset. We only augment 1 of 10 training dataset, so using large dataset will be help to solve this problem. The second method is making user context more rich by editing more user context. And final one is randomize user context order because user context is already arranged by importance, but it causes error by using first or second user context word when generating captions. And this is the end of our presentation, and thank you for listening.